Leptos' first official release, 0.1, is now available on crates.io. Leptos is a full-stack framework for building web applications in Rust that can be used to build client-side-only apps, server-side-only apps, or both by rendering on the server and then hydrating on the client. On the client side, Leptos compiles to WASM, while on the server, Leptos runs as native Rust. Architecturally, Leptos picks up and runs with the recent popularity of signals in the UI ecosystem. So typical modern UI concepts like prop, state, and context still exist when defining components. In Leptos, however, you'll find yourself passing around a special scope variable, which is how the runtime handles tracking and reacting to updating signal values. You'll also find some other minor differences like custom event handler attribute name. I've been using Leptos to rebuild one of my production applications, so for me the biggest features of the 0.1 release are the newly added support for the tracing crate and a big push towards using Cargo Leptos. I also really enjoy the Builder API, which allows you to use a Builder API instead of the View macro, making dynamic components much more accessible. So Cargo Leptos then is a Cargo subcommand that helps build and develop Leptos applications. It does quite a few things, but the main things it does is handle setting up and building the server-side and WASM projects, and then also handling things like CSS, for example. So to get started, we'll have to cargo install Cargo Leptos. With Cargo Leptos installed, we can actually see a number of the packages or crates that are used building Cargo Leptos, which then helps us in turn build our Leptos applications. One of the most interesting, I think, is Lightning CSS, which started out its life as parcel/CSS, but is now just a CSS implementation in Rust. We can use Cargo Leptos, the new Cargo subcommand that we just installed, to create a new repository using Cargo generate under the hood, which looks for the github.com leptosrs start repo. So I'll run that, and it asks us for a couple of things. In this case, I'll name this ytleptos01 and hit enter. And we've brought in a number of different files, including some files in source, including main.rs and lib.rs. We've got a style main.scss, but we can get our way into ytleptos01. If we use bat to look at the README, we can see some nice colors here, and if we go down to the bottom of the file, it tells us how to run the project, Cargo Leptos watch. Now Leptos still uses nightly Rust, so Cargo Leptos will prefer nightly Rust. They've also chosen SCSS or SAS as the CSS implementation for us. I personally tend to not use SAS, but for this example, it's just as good as any other option. That's the only binary that I don't have installed already, so I'll do npm ig SAS and run Cargo Leptos watch. Interestingly, when I tried to use Cargo Leptos like this, it didn't use nightly by default, even though the docs said it would. I was able to solve this by using a Rust toolchain file that used a specific version of nightly. In this case, it's the nightly from 12/25/2022, because I did copy this file from somewhere else. So we can see that Cargo Leptos has now run Cargo build with the Leptos start package. We're building the library. It happens to place some of the artifacts in the target front folder. We're building for WASM, so this is the WASM bundle. We're running with no default features and selectively enabling hydrate. So this is the build for the front end, for the WASM bundle. Then we can see the second command is Cargo build for the Leptos start package. For the Leptos start binary, in the target dir, we have target server instead of target front. Again, no default features, with the SSR feature specifically re-enabled. And then we're using notify to also watch any of the Rust files in the source folder, any of our styles, and any of our assets. If we run this again quickly, you'll see both projects getting built. And with Cargo Leptos watch running, we can see on localhost 3000 our Leptos site. If we look at the network, we can see the WASM bundle, the small JavaScript that bootstraps the WASM bundle, as well as the CSS. I will point out, since it's here, this is a development WASM bundle. The production WASM bundle gets much smaller, gets a bunch of the debug symbols and things stripped out. So if we take a look at our new Leptos app, we've got assets, including a favicon. We've got some end-to-end tests that I won't be covering. We've got source app, lib, and main, and we've got style main.css. So one of the really nice things is that if I type some colors into here and I save this, Cargo Leptos takes care of sort of hot module reloading things like our CSS styles, which is really wonderful. I'm going to do a quick dark mode on this page because I like dark mode by using filter invert 80% and a background of black. Now in a Leptos application, the main.rs is going to be your server. So in this case, we're using Actix. My personal preference, and the one that I'm using in my other project, is Axum. So there are two actual integrations that you can use, Actix and Axum. In the server file, we basically get some configuration. We set up any of the routes that we'll need to handle. There's something called server functions that we haven't covered yet in this video, and we specify that we should handle those at /API. Otherwise, we handle any of the routes our application should handle and serve any static files on any fall through routes. lib.rs is where we set up our WASM bundle. So this is the entry point to the WASM bundle that will run on the client side. In this case, the logging was initialized with the log crate, but there is now support for tracing, which I much prefer because all of the rest of my Rust applications use tracing, and I use distributed tracing to get a look at where a request comes from, how it flows through my infrastructure, and what happens at any given time, all in a single trace. So in the WASM bundle, we use Leptos mount to body with the scope context that we talked about earlier. So the view macro uses the scope context and then renders our app component. This is the same thing that's happening on the server. We've got our view macro, the scope context, and the app component. So app then is just our application. It's all of the code that will run either on the client or on the server. In this case, we're exporting a component called app, which makes use of a component called homepage. One of the changes in Leptos 0.1 since the pre-0.1 days is that these components now return impl into view. So we have components that accept a scope and return something that can be turned into a view, basically. Provide meta context is sort of a special usage of context that allows you to set things like meta tags. In this case, we use the style sheet component to point to our compiled CSS file. Notice this is /pkg. It is not pointing to the main.scss file. Here's a title component that sets the title tag. And then we have Leptos router brought in here, which allows us to define a set of routes in very similar ways to other routers. So we need a router wrapper, sort of like providing the routing context. Then we can specify a group of routes that we want to handle. In this case, we only have one route. It's the root route. And you can see that page being rendered on the left-hand side here. So this homepage will get rendered at the root route, and all of the route's content will get wrapped in main. Homepage, very similarly, starts using signals. This is the first usage of signals that we've seen. This is very similar to hooks, if you're familiar with those. We create a signal using the current scope. So this scope is tied to this component's lifecycle. We set the default value to 0. Count becomes a signal, and set count will allow us to write to the value that is contained inside of that signal. So count is a read signal and set count is a write signal. You can split a signal into these two pieces. OnClick is an event handler. So we move any variables that we're capturing, in this case, set count. Because set count is a write signal, the update function allows us to define how to update that value. So when we do onClick in our button, we run the onClick event handler, and we can use the write signal to update the value inside of that signal, which will then re-render out using the read signal, just updating this button. So that's Leptos 0.1. There are a number of features we didn't talk about. There are examples for the tracing infrastructure in the Leptos repo, if you're interested in that. That is also going to change soon, though, so I decided not to show it and instead just to point you to it in the repo. I've been quite enjoying my usage of Leptos recently in another project that I'm working on, which will wrap up and do a video. So definitely go take a look at Leptos if you're interested in Rust and WASM UI frameworks. And have a great rest of your day.